Well, today I'm going to explain one question of testing of hypothesis, one sample. And that is to be done with the help of the Excel sheets using data analysis tool. So let us go to the question directly, and I'm going to share the question to you over here. So the question is like this. So this is my question, which I'm showing you here, and I'm going to explain how to answer this question. So if you read the question, the file fast food UK, this is the data where you will get the data, contains the amount that a sample of 25 customers spent on lunch in pound at a fast food restaurant in London. So this is about the data given to you. The city London, 25 customers, food habit has been explained. What you are asked to answer is this question number A. At 5% level of significance, you have to check, is there evidence that the mean amount spent on lunch is different from 7.50 pound? So this is what we are going to test. So according to our method of testing of hypothesis, I will have to first decide the null hypothesis and the alternative hypothesis. In the question, they want me to check that the mean amount is not equal to, different from 7.5 means not equal to 7.5. So this mu not equal to 7.5 is going to be our alternative hypothesis. So accordingly, the null hypothesis will become mean equal to 7.5. So this is the first step to decide about the hypothesis. Now we want to verify this one. Before verifying this, I will be going to the data. Look at here, Data Analytic tool. And there, I will be going down last but one. This is the t-test 2 sample assuming unequal variance. I will be clicking this one, then going to over here, okay. But before that, I would like to explain you that since this is going to use 2 sample, so I have to create one dummy variable over here. So I have already my data here. This is my data available. So this is one sample. Because it is using 2 samples, so I will be creating a dummy variable with 2 zeros, that's enough. So I will be using this dummy variable. Once I have used this dummy variable, I will go to use my data tool, starting with this variable 1, the first variable I will be selecting first. So this is my first variable with the title. So I choose this. So I have already selected this. Then I will go to select the second variable here, which is this dummy. This is enough. And I did it. Now I will be filling up this one. This one will be the value of the mean that you have that are given in the question. You will be just copying that down over here, right? 7.5. You'll be putting here 7.5. This is here. Oh, I'll be choosing this value. Yeah, I'll be choosing here 7. Why it is not? Okay, I'll be writing from this 7.5. So I have checked the level. You already see here the alpha is 0.05, which is 5%. Now you want to get the data. So here is output range. And I will choose, okay, I will choose the place where I will go down here, because I have already done this before, but I just want to show you how I got it. So I will be selecting this one, and then I did it. So it's all done here, nothing more to be done. Then I just do okay. I will get I will get this data which I have already obtained over here before, just to check the reference of. So this is how you will also get this one. This data which I am just now got is similar to what I got it before. So I will be using this here for explaining the question. Just ignoring this right now, but you will not be able to ignore, you will be using this one. So what are the important thing over here to be highlighted is the T statistics. The T statistic is this one. And this is going to be the two-tailed test. You will be taking the probability for the two-tailed test and as well as T-critical two-tailed test. So these three things, 1, 2, 3, is going to be used for answering our questions. So now to answer the question whether this is true or that is true, so I will be comparing my T statistics with the T-critical of two-tailed test. So look over here, our T critical is 2.06 and T stat is 0.97. So T critical is less than this. That means it is falling in the non-rejection region. So I will be saying that since T value is smaller than the T critical, we fail to reject the null hypothesis. This will be my observation. We fail to reject our null hypothesis. So according to this question, we have already said that we fail to reject the null hypothesis, means there is no evidence that the mean spent on lunch is different from 7.50. So you have proven that the mean average is 7.5. This can also be proven by using the probability, which he is asking you here. Determine the p-value in A and interpret the result. So p-value over here is 0.33896. If this p-value is less than 0.05, then we reject the null hypothesis. But we see here, this p-value is greater than p-value, this one is greater than 0.05, so we fail to reject null hypothesis. So with the probability and with the t-stat, we are arriving at the same answer, but this is the answer of the question B, this is the answer of the question A. Now, the question C is saying here, what assumption must you make about the population distribution in order to construct the t-test in A and B? Now you are well aware that the hypothesis testing is done with the help of z-test as well as with the t-test. But why we are using here t-test? Because in the question, population standard deviation is not given. Population standard deviation is not given. So we will be using t-test over here. So the sophisticated answer is shown here. You must assume that the distribution of the amount spent on lunch is normally distributed. Okay, because there's a not given, so I will be assuming it is normally distributed. And if you want to show this normality, then you can draw the box and whisker plot of this data. How you will be doing? You will be just going this, insert here, go to this one, okay, and now select the data. Select the data here, select the data. So insert this, and if I check this, I will immediately get, you look, this is quite symmetrical. Look, this, the Q2 above and below, the values are almost same. So it is already saying the normality of the data. Okay, it is not required. This answer in your exam will be enough, but to make you understand, I have shown you that this is symmetrically distributed, so it is going to be almost normal. Also, why this question is arising? Because the sample size is less than 30. Sample size is less than 30, then the normality concern arises over here. Since the data is almost symmetrical, this concern is can be ignored. And this is the answer of the question D. Question D says, because the sample size is 25, do you need to be concerned about the shape of the population distribution when conducting t-test? The answer is yes, but because I have just now seen over here, it looks to be symmetrical, So you have nothing to fear about the normality. So here is the answer. With a low sample size, it is difficult to evaluate normality. However, the distribution seems to be fairly symmetric with no serious violation of normality. So this is the answer of all these questions. Similar type of questions usually come in the exam. So you can go to the testing hypothesis topic and you can solve one or more question. You will be able to do it easily. So this is the end of this question. Hope you understood this and you will be able to deliver in the exam if it comes. So I am just signing it out from here. So wish you good luck. I will stop here my recording